Hello all, welcome to our channel. Where to know? In this video, we will see how to create footprint for LM7805 linear regulator. So LM7805 has several packages available. If you see here, it is available in DPAC TO263, SOT223, TO220 and TO3. So in this video we will see how to create TO220 package. So when you open the data sheet, the package information shall be available towards the end of the data sheet. So we know that we have to create TO220, right? Let us go towards the end of the data sheet to see the dimensions of TO220 package. So if you see here, this is the TO220 package dimension, and as we see here, there are three leads. So there are two ways this component shall be mounted on the PCB. One is you might mount it vertically, or some users want to bend this component, the bend the leads, and then tie with a nut to a left out copper on the PCB. So two ways people can mount this. For now, uh, we will consider mounting this component as a vertical component. So when you want to mount this vertically, you know that you need three holes, right? So and the total space that is occupied, if you see here, it is around 4.45 to 4.7. That means that much space is required. So three holes with the component space of that much is required. Now let us go to Kicad and see how to create the component. So Kicad, if you see, once the component is created, it looks this way. So let us see how to create this component. Okay, so first thing, this is a through hole part, right? So add a pad, okay, pad here, and then this is the first pad into which the component can be soldered, and we want a through hole pad, right? So double click on this, and it's here you will have an option to select whether it is SMD through hole, edge connector, or NPTH hole, or SMD aperture. So select through hole, and pad number, you will start from 1 because we already had three holes there. It has shown as 4 1, and try to start with so for now we placed it above the existing part, right? So 0 and minus 762 is what it is there, and then you can see here the whole shape we are keeping it circular. This is the hole, and this is the pad around which the component will be soldered. Now this whole dimension, right? How to know the whole dimension? If we go to the data sheet, see, you can see here, when we solder this component, we will insert this particular part of the regulator to the hole and then solder it. We will not insert this particular part. Okay, so if you see this part, this is the width of the pin. So it is 0.69 to 0.74. So if you average this 0.69 to 0.94, you will get the value which can be used, which comes around 0.85. So that's why we the whole shape we will keep 0.85, and then it is circular, and pad shape is also circular, and we will keep the dimension almost double of it so that you will have a proper soldering. Okay, so this is how we create a hole, and then when we press OK, you have the pad ready. Okay, now if we go back to the data sheet, the distance between each pad, if we see here, is 2.29, 2.79, which average comes around 2.54. So that means the whole dimension, the whole spacing of the regulator is 2.54. Now let us have a grid of 2.54 here, and let us click on this, right click, copy and paste. And if you see here, uh, this grid from 0, you can see in the bottom, the grid x shows 2.54, and then you can double click here and say this is a 2 pin 2. You can see position 2.54 and y axis is the same, and the dimensions are the same, and click OK. And then again go here, copy, paste. Okay, you can see again a 2.54 mm. Double click on the part, make it 3, and it is 5.08, 0, 2.54, 5.08. That means each pads are at 2.54 interval with the same dimensions, and press OK. Okay, and now you have to add a outline for this component. So to add outline, click on this rectangle, and as it is a 2.54 mm, you draw the rectangle, and you can make it as per your dimensions. So if we go back to the component, we see that component is around 4.55 mm space that is required. So within which you cannot have any other components. So that means from here till here you should have 4.54 mm of dimensions, and the length again you can have based on the data sheet, which is around 10 mm. 10.16 you see here, 10.16, and if you consider zero point 0.4, 10.5 mm. So you will have 10.5 mm of width here. So that's how we do create the outline for this. So you select appropriate dimensions for this, the starting point and ending point based on your requirement, and draw this. So this is how the component is available, and then for this particular part. So now once this is done, we'll delete the duplicate which is created, right? So the same part which is created down, and you see here there is a circle that is indicated, which is nothing but silk screen. So click here, okay, and we can draw a circle as per our requirement. Okay, it's basically drawn as a circle here. Okay, you can change the grid here to place it properly. Double click on this, and you can have filled shape, and this is on the sill screen. So you can place it nearby by changing the grid here. So this you can do easily. So once all these are done, this is how the part looks, and this is the footprint name for the component. This is, if you want, you can change it here as per your requirement and change the positions. So the footprint name is also provided. So 7805 simple footprint is available. In the other video, we have also shown how to add footprint to a symbol, right? So do follow that video to add this particular footprint to the symbol. Hope we gave a glimpse of how to create footprint of particular component in Kicad. Please post if you have any questions. Please like and subscribe our channel. Thank you.